So we are now being recorded. If you have a question, you can click the chat button. It's either at the top or on the right side, and you can ask a question there, or there's a Q&A button, and I'll periodically check the chat and the Q&A buttons throughout the time. I'll pause and check for those. And in case, I will go ahead and get started. I just want to mention that in order to hear, then you need to either call in or use your computer to hear the what's happening. Yes, there's a question in the chat box. Am I speaking? Yes, I am. So if you need to, there's people who can't hear anything. I'm going to pause the recording for a moment. Okay, so the event is being recorded. Just want to clarify that. And that's for people who are unable to attend live, or if you want to listen in at another time, again, that's fine. There's no need to take frantic notes during this whole presentation because the entire document I have saved as a PDF file. So I can send it as an email, and I will send it to all the MAT 115 instructors when we're done here, so that you can have the audio, the file. Okay, so what we're going to be doing during this time is understand Venn diagrams. So I'm going to spend a little bit of time talking about the basics of a Venn diagram and how it's set up. And then we're also going to draw Venn diagrams to illustrate application problems. So we'll be using Venn diagrams to help with some word problems. And we're also going to look at something called cardinality of a region of a Venn diagram, look at the notation for that and what that involves. And then we're going to use the Venn diagrams to answer some questions about the word problem, and also look at common mistakes so we can avoid those common mistakes when it comes to working with Venn diagrams with surveys, word problems, that type of thing. And I'll pause periodically, check the Q&A box and the chat box to see if there are any questions. So first of all, a Venn diagram is a useful way to illustrate the relationship between sets. And think of a set as just a basket. So you have a collection of objects in a basket. That's a set, and a Venn diagram helps us to show the relationships between those different sets. And we start off with a rectangle, which represents the universal set, and we call that a capital U. And inside the universal set, we put the circles that represent the subsets of the universal set. So the U is the universal set. If you think about it, it's like the universe of the problem. It's what the problem entails. And then if there's our little subcategories inside, those would be the circles. And so here's an example of two subsets and the universal set. So here we have the universal set, and that's the U. We normally stick the U like in the corner somewhere to represent the universal set. And here we have set A and set B. We name them different, you can name them different things depending on the situation. The blue section is what's common to both. So when you have like two baskets overlapping where maybe there's an object that's in set A and set B, that would go in the blue region. And this region over here would be just for elements, things that are in set A but not in set B. And then this region over here, this piece, would be for anything that's in set B but not in set A. And then this that I'm coloring in purple is whatever's part of the universal set, there's our universe, okay, whatever's part of the universal set but is not included in either of those subsets. So sometimes there are objects in that purple region as well. So that's what it looks like when you have two subsets inside the universal set. So here's a useful way that Venn diagrams can illustrate relationships in a situation. So we're going to look at a particular situation. The Marty family is moving to Washington, D.C. Their real estate agent located 83 houses listed for sale in the D.C. area and in their price range. So of these houses listed for sale, 47 had a family room, and 42 had a deck, and 30 had a family room and a deck. So that's the situation, and what we're going to do is use a Venn diagram to illustrate what's happening with the houses in this situation. So the universal set is going to be all 83 houses. And then the subsets, one of the subsets would be the family room, the houses with just the family room, and another subset would be the houses with a deck. So in this case, the universal set is the 83 houses. The two subsets, there's the houses with the family room, the houses with the deck. So we're going to let subset A be the family room, and then B be the houses with the deck. And then the section where circles A and B overlap would be the houses that contain both a deck and the family room. So it would look like this, and we have our universal set is the box, and we have the family room circle, we have the deck circle, and then we have a section in the middle where those two circles overlap, and that would be both. So the houses that have both a family room and a deck would be in the overlapping section. Now what we're going to do is put the numbers in the diagram. Remember that the word and means the intersection of the two. So the houses that have a family room and a deck would be included in the overlap of the two circles. So that's where we're going to start. We know there's 30 houses that had both a family room and a deck. That was given in the information. So I'm putting that in my picture. Now there's something I'd like to point out in this situation. If we go back to the problem, right here, we'll go back. If we go back to the problem, we'll see that the 30 is at the bottom of the list in my situation. I see the number 83, I see the number 47, I see the number 42, and the number 30 is at the end. With these, a common way to work the problem is from the bottom of the list and work your way up. A lot of times it's written like just how it's written in this type of format, and when you're filling in the Venn diagram, you actually start at the bottom. So just keep that in mind, and that's something we're going to do again a little later on with another example. Okay, so we're also told that 47 houses have a family room. This means there should be a total of 47 in the family room circle. So if we look at the family room circle, notice that in the family room circle, I already have 30. So what I need is 17 more houses in the family room circle, which looks like that. So if I look at my family room circle, I notice that 17 plus 30 is 47, and I have the 47 houses that I need. Notice I did not write the number 47 anywhere in my diagram, okay? That's a common mistake, so that's one of the things we're going to take a look at as a common mistake. But what's important here is that in my family room circle, I have a total of 47 houses. We were also told that 42 have a deck. This means there should be a total of 42 houses in the deck circle, and there are already 30 in the deck circle because of the overlap. So I'm going to take 42 minus 30 and get 12. So that means I need 12 more houses in the deck circle. So if I look In my deck circle, I have a total of 42. So when we're told in the problem that 42 houses have a deck, that does not mean 42 houses have only a deck. The word only wasn't written there. It's just saying if I look at all the houses with a deck, I total 42. So in the deck circle, we should have a total of 42. Now, it may look like we're done, but not really, because if I add 17 plus 30 plus 12, I don't get the 85 total that we're supposed to get. Okay, we get 59. So that tells me that some of the houses had neither a deck nor a family room. And these would be the houses that are inside the universal set because I have 83 houses in my universe, but they're not in those subsets. And when I subtract, I see that I need 83 total in the rectangle. I have already 59, which means there's 24 left. And those 24 then would go in my universal set. So anywhere, that 24 would go anywhere inside the box as long as it's not in any circles. So that's something to keep in mind, that that 24, it's kind of floating around in the universal set, but not inside the circle. So when I look at this, I can see, first of all, if I add 24 plus 17 plus 30 plus 12, I should get the total that I have in the universe, in the universal set, so we're good there. And if I take a look at what this is telling me, it says I have 24 without a family room or deck. I have 17 with a family room and no deck. I have 30 with both, which is something we already knew. That was the information in the problem. And it also tells me I have 12 with only a deck, not a family room. So that's what each of those numbers means. And once we have the diagram completed, we can answer the questions, answer questions about the situation, because with these homework problems, they'll give you the situation and then a list of questions. So after I fill in the diagram, I can look at the questions and answer those. So I have a list of sample questions that go along with this situation. Also, I'd like to talk about the cardinality notation. So when we talk about cardinality of a section or of a region is basically the number of items in that region. So if I talk about the cardinality of this section right here, the cardinality would be 17, okay? If I talk about the cardinality of the deck circle, that would be 42. So really it's just adding up the numbers. It wants to know how many houses are in each of those regions. That's cardinality. So it's just another word basically describing what we're doing, okay? But I'm going to also use some cardinality notation to go along with these questions, just to get used to the notation, because sometimes in the directions to the problems, it will give you the notation but not the wording. So it's important to be able to read both. Okay, so how many houses had a family room but not a deck? And before we get to the cardinality, the notation for cardinality, let's just look at the question. How many houses had a family room but not a deck? So that would be 17, because it's in the family room circle but outside the deck circle. Okay, now let's take a look at this notation. This little n in the front of the parentheses is meaning number of, really. Number of houses is what they want to know. And the cardinality is what they're asking about here. Okay, so this is asking about cardinality, which means the number of houses in that region. Now let's take a look. I used FR for family room and D for deck. Okay. So it wants to know the number of houses in the family room, and this D has a little apostrophe thing on it. That's basically saying what's not in the deck circle. Because if we look at the directions, it says, but not in the deck circle. So I can't just write a D. I have to write a D with the apostrophe, meaning not deck. If it was the deck, I would just write a D. But not deck is a D with the apostrophe. So what this is saying here with this like upside down U symbol is saying what region will overlap the family room circle with what's not in the deck circle. So this is saying look inside the family room circle and outside the deck circle, which is what we just did right here. This is inside the family room circle and outside the deck circle. Generally, this symbol is the and symbol. If you have it up like that, that's the or symbol. So I'm going to read that as an and say how many houses. The little n in the front is basically saying how many houses. Okay, so this little n wants to know number of houses in the family room circle and not in the deck circle. So again, that's that region right there, which is 17. So the answer to this is 17. And written in sentence form would be this. Written in with the cardinality notation would be that. So those are basically asking the same thing. The answer to both is 17. Okay, so I'm going to just check the chat box for a minute and see if there are any questions. Okay, so let me clear this out and move on to the next question. How many houses had a deck but not a family room? So we look at the question, the number of houses that have a deck are inside the deck circle, but we have to also look not in the family room. So that would be 12. That's the answer to that question. And then this is the cardinality notation right here. And again, meaning number of houses. And notice I have the or symbol again, the and symbol again. The upside down U is the and. So this is saying deck and not in the family room, which is exactly what the question's asking. So inside the deck circle and not in the family room would be this piece right here, which again is the answer 12. Okay, here's another question. How many houses had a deck, a family room, or a deck? Remember I mentioned that this symbol is the and this symbol is the or. So you notice that in the parentheses it has the or symbol, and in the question wording it has an or. So again, the question is in word format, the symbol with the parentheses and all that is in symbol format, okay? So it wants to know how many houses had a family room or a deck. Now, when you're working all these problems in this chapter, the word or does not exclude both. So when you see the word or, it really means family room or deck or both. It doesn't have to mean only one of the two. It means family room or deck or both. So to find this answer, I'm going to add up all the numbers inside my circles that I see there. And to get the answer of family room or deck or both, and you get 59. So the answer to that is 59. And if you take a look at the notation, it's really asking the same thing, FR for family room, the U symbol means or, and then D for deck. So the little n in the front means number of houses, and in the family room or the deck. So it's just the notation of saying the same thing as the question. Okay, let's take a look at another question. How many houses had neither a family room nor a deck? So what they're asking us to look at here is everything that's in the universal set, but not inside those circles. And when you look, the answer is right here, 24. There are 24 houses in the universal set without a family room or a deck. And in notation, that would be, there's the word or with the U, so family room or a deck, but the apostrophe right there means not the family room or a deck. So that's basically saying like the opposite of this. This we had family room or a deck, which was all of these numbers. And then when we come over here, it's the same question, but it's a negation of it. So it's basically anything outside of this, but it's still inside the universe, which is 24. So that apostrophe again is meaning not inside the family room or deck circles. And the answer is 24. Okay, so that gives us some questions with 2 circles inside the universal set, but some have more than 2 subsets inside the universal set. So the other types of questions you'll be answering have to do with 3 subsets. So let's take a look at what 3 subsets looks like. We have subset A, B, and C inside the universal set. And notice that we have more regions now. This region is actually inside all 3 circles. So if there's something, if there's like in this, the house, one we were just looking at was houses, if there are any houses that have the 3 characteristics of whatever A, B, and C would be, they would be in that green region right there. So that's where you have an overlap of all 3. Then if you notice, we have this, which is an overlap of circles B and C, B, A and B. This is where A and B overlap. Now, if we looked at it as just this piece, this is where A and B overlap, but it's outside of C. So you have A and B overlapping, but it's not in circle C. So that's a special region there. And then we have the same type of thing happening between circles B and C. That's where B and C overlap, but this filled in region is where B and C overlap outside of circle A. We have the same thing happening between circles A and C. This is the overlap of circles A and C, but this region right here is the overlap of A and C, but what is outside of B. Then we have this piece, which is inside circle B, but not in either of the other 2 circles. This piece is inside C, but not in either of the other circles. And then this piece is inside A, but not in either of the other circles. So knowing all that, we have all these different regions, and we're going to look at a situation here and try to put the numbers in the right spots in our diagram. And it's really important that when you, so we're going to look at an example with 3 subsets, circles A, B, and C. It's really important that when you look at a problem like this, that you read it, but then you start to fill in the diagram and then answer the questions that come after it. I just wrote the problem. I didn't even write the questions yet on the screen because we're not even going to look at those yet. It's tempting to read this list and then go through the list of questions and try to answer them, but that's not going to work. What you have to do is read the list and then draw the Venn diagram. And just like we did in the last problem, we're going to use the Venn diagram to answer the questions. Because if you notice, the answers may not be on this list. Like in the previous problem, when we looked at a question like this one, the number 59 was not actually in the problem. We had to add these numbers to get to the number 59, and the number 12 wasn't in the problem. So like when we fill in the diagram, we're actually gonna have to use some numbers that are not listed here because we're gonna be doing the same type of subtraction that we did before. Okay, and before we move on to this example, I'm going to there's a question that was in the chat box that says, if and matter, do you add them together when the apostrophe is missing? So if you have, like, we'll go back to this one with the and. Okay, so it's asking and with the apostrophe missing. If the apostrophe was missing, it would look like this. And so that would be the overlap of the deck and the family room, which would be this piece right here. Overlap of because it would be deck and family room, so the only houses that would be included with that would be deck and family room, which is those 30 houses that have both. Okay, so if the apostrophe is missing, and you have the and, you're looking for the overlap of the two. That's a great question. Let me see if there's any other questions. Okay. So let's start this next problem where we have 3 circles. And so we have a survey of 85 amusement parks. It's found that 24 had a hotel on site, 55 had water slides, 38 had a wave pool, 13 had a hotel and water slides, 10 had a hotel and wave pool, 19 had water slides and a wave pool, and 7 had all 3. I know that's a lot, but that is why we have the Venn diagrams, to help us organize all this information to be able to answer questions about the situation. So when I look at this, I see in the first sentence that my universal set has 85 parks. So when I'm done with my Venn diagram and I add up all the numbers in the Venn diagram, it should add up to 85. Now, if you notice, if you add up all these numbers, you don't get 85. Okay, so it's not so simple as just taking these numbers, and throwing them in the picture. We're going to have to do some subtracting like we did in the last problem. And notice in the last problem, we started at the end of the problem where we had the overlap of the circles. We're going to do the same thing here and start at the bottom, because this tells me that where all 3 circles overlap, there are 7 amusement parks. So the 3 subsets are going to be hotel, water slide, and wave pool, and the diagram is going to look like that. We have our universal set, which is the box, and then we have the 3 circles, and notice we have all these regions with the circles overlapping, and where all 3 circles overlap is in the very middle, right here. And I'm told at the very bottom of my list that 7 had all 3 features. So I know in that little section I'm going to put a 7. So that's where you start. It's really good to start in the middle of the picture and work your way out. And when you start in the middle of the picture, many times that means starting at the end of the list of given information and work your way up, which is kind of something you have to sometimes force yourself to do, because human nature is just start at the top and work our way down. But I don't know why this is how all these problems are written, not just in this book, but in other books I've seen. They write all the problems this way, and really it's best to start at the bottom and work your way up. Okay, so we're going to take the information from the problem and fill in the diagram. The key is to complete the inside of the diagram and work your way out, okay? And I just mentioned start at the bottom of the list of information is a good place to go. So I know where all 3 circles intersect, it's a 7, because we're told that 7 amusement parks had all 3 features. And for some of these, I will use the cardinality notation, and some I won't. So just to keep that going throughout this, throughout this. Now I could write that in here. So the number, I didn't put that on the screen, but the number of hotel intersect wave pool intersect water slide would look like that, where you have the intersection. So it's the and. It's wave pool, hotel and wave pool and water slide is what that would look like, and then the N in the front to show that's the number of amusement parks with hotel and wave pool and water slide. The answer is 7, like that. Okay, and like I said, throughout some of these, especially when we get to the questions, I'll write those in some cardinality notation just to get used to that as well. Okay, so moving up the list of given information, I started at the bottom and I'm working up. And the next thing up tells me I have 19 amusement parks with water slides and wave pools. So that tells me in the water slide and wave pool intersection, which is this piece right here, I should have a total of 19. I already have 7 because 7's in the intersection of all 3. So I'm going to take 19 minus 7 and get 12. So that's why I wrote a 12 in that region in the diagram. So 19 amusement parks have water slides and wave pools. So that means in the intersection, which is right there, I should have a total of 19, which I do. Now, a common mistake is to forget to subtract and put like a 19 right here instead of a 12. So keep in mind you're going to be doing a lot of subtracting with putting the numbers into the diagram. Okay, so then moving up the list again from the bottom, we're told 10 amusement parks have a hotel on site and a wave pool. So that would be the intersection of hotel and wave pool right here. And I have a total of 10, so that means I need to fill in a 3 in that region because 7 is already there in the overlap between wave pool and hotel. Moving up the list, we're told that 13 had a hotel on site and a water slide. So if I look at the intersection of hotel and water slide, I should have a total of 13. There's already 7 in the middle. So in the other region, I need to put a 6, which totals the 13. Okay, so continuing up the list of my given information, I see there are 38 amusement parks that have a wave pool. That means in my wave pool circle, the whole circle, I should have a total of 38. I already have 7 and 12 and 3. I already have those. So I add them up and I see that's 22. But I'm supposed to have 38, so I subtract and I see that I still need 16 more. So in this section, in the wave pool circle, I put a 16 right in here because this is the region I need to fill in next. So now when I look at my entire wave pool circle, I see 3 plus 7 plus 12 plus 16, which does give me 38. So 38 had a wave pool. In my wave pool circle, I have 38. Notice in my diagram, I did not write the number 38 anywhere. Okay, so this is where, like I said, you need to be careful. You can't just take the numbers in the problem and put them in the picture. It doesn't work that way. The 38 with the wave pool just means inside the wave pool circle, you should have a total of 38. The next one says I have 55 amusement parks with a water slide. So in the water slide circle, I should have a total of 55. When I add up the numbers that are already there, I have 25, so that tells me I need 30 more, so I put a 30 right there. 55 minus 25 is 30. So now my water slide circle totals 30. Next, we're going to do the same thing for the hotel. We were told that 24 amusement parks had a hotel. There are 6 plus 7 plus 3, which is 16. But in my hotel circle, I need 24, so that means I need 8 more in that spot. Okay, now looking at this, it may seem like we're done, that we don't have anything else to fill in, but not really. Because if I add up all the numbers, I don't total what I should. First, though, this is just showing my double check here. When I look inside the hotel circle, my numbers add up to 24. wave pool add up to 38, water slides add up to 55. So that's a double check to make sure that inside each of the circles I have the correct number of amusement parks. And now I add all the numbers in the diagram together, and it comes up to 82. But I was told at the very beginning of the problem, in the very first sentence, that I had 85 amusement parks, and so that tells me that 3 had none of those features. Sometimes this is an easy step to forget because you get so focused on the circles and the regions inside the circles that it can be easy to miss this step. So make sure not only that the circle totals are correct, but that the entire diagram has the right number in it for the universal set. This was the very first sentence in the problem, the 85 amusement parks, and of course we're doing it last because we started at the bottom of the problem and worked our way up to the top. So once the full diagram is complete, it looks like that. And there's my universal set is in the box. I have hotel, wave pool, water slide, and all the numbers filled in the correct places. Once you have this, you can double check and add all the numbers together, make sure it gives you 85. You can go ahead and answer questions. So let's take a look at some questions that might be asked from this. Okay. Also, I'm going to use some cardinality notation with some of these questions just to get used to that as well. So how many amusement parks surveyed had only water slides? So that means we're looking for inside the water slide circle, but not in the hotel or wave pool. So in my cardinality notation, I use WS for water slide and WP for wave pool just to make things easier to work with. So how many amusement surveys has only water slides? So I'm looking in the water slide circle, and I have to find the number that's in the water slide circle, but not hotel or wave pool. That would be 30. So after the diagram's filled in, to answer the questions, you're looking at the diagram and taking the information from there. You're not looking at the list of given information anymore. I'm not going back to the original problem. I'm looking just at my diagram. Okay. Now, if we look at this notation, the letter N in the front, again means number of. So I need to see like the number of amusement parks that have water slides and not hotel and water and wave pool. So not hotel and wave pool, that's what this apostrophe thing is for, saying not hotel or wave pool. So it's water slide and, the upside down U is and, so water slide and not the hotel or wave pool. And that's what gives me the 30. So in sentence form looks like this, but notation looks like that. Water slide and not hotel or wave pool. Okay, let's look at another question. How many amusement parks surveyed had exactly one of these features? Exactly one. So that means hotel but not wave pool or water slide but not hotel or wave pool, and wave pool but not hotel and water slide. So this 8 right here has hotel but not wave pool or water slide, so I'm going to use that, those 8 amusement parks. And this 16 had a wave pool but not a hotel or water slide, so I'm going to add 16 to that. And these 30 had a water slide but not hotel or wave pool, so I'm going to add 30 to that. And that's going to give me my total of 54. So the answer to the question is 54. Okay, I looked at, there we go. I looked at the number of hotel, number of wave pool, number of water slide that only had that one feature and not the other 2, added that up, and that gives me 54. Okay, just looking in the question box again to see, or the chat box to see if there are any Other question. There's a question that says, what is this formula? If you could clarify that question, I'm not quite sure what you're asking about on that. Okay. All right, let's take a look at the next question. How many amusement parks surveyed had at least one of these features? So could have two, could have all three. And so basically, we're looking at everything that's inside that region where all of the circles are. One way to do this is to add up all the numbers, or just take the total of 85 and subtract that 3. So either way, that's fine. How you want to do that, you should get 82 as your answer, because if it's at least one of these features, that means it's in at least one of these circles. So if you take all those numbers and add them up, you get 82. Or you could look at the entire universal set of 85 and take away that 3, and you end up with 82. And in the cardinality notation here, the little n in the front for number of, we're looking at number of resorts with hotel or wave pool or water slide. And remember, the or also means it could be more than one, like it could be one or the other or both. So it's all of those numbers in the diagram there. Okay, let's look at another question. How many amusement parks surveyed had exactly 2 of these features? So exactly 2, so that would mean hotel and wave pool, but not water slide. That would also mean, so that's 3. That would also mean hotel and water slide, but not wave pool, so it's those 6. Move that down. That would also mean wave pool and water slide, but not hotel, which is 12. So I just add those numbers to get 21 as my answer. Okay, so exactly 2, meaning hotel and wave pool, not water slide. Hotel and water slide, not wave pool. Wave pool and water slide, not hotel. So you take those numbers and add them up. You can see how really, really difficult it would be to answer this question without the Venn diagram. If you just looked at the list of given information in the problem, you would have a really hard time coming up with an answer, because these numbers 3, 6, and 12 are not in your list of given information. We found those by looking at the Venn diagram. So, okay, next question. How many amusement parks surveyed had none of these features? So that's saying hotel or water slide or wave pool, but because of the not, there's the apostrophe there. So it's everything that's not in the circles, and that would be 3. 3 is the number of amusement parks not in the circles. So and if you notice, for all of these answers, we're looking inside the box. We're not looking outside the box. The universal set is basically everything in the universe for that problem, and you have to look inside the box to get the answer. So how many of these 85 amusement parks had none of these features? That would be 3. Okay, another question. How many amusement parks surveyed had a wave pool and a water slide, but not a hotel? So wave pool and a water slide means it's here, but not a hotel means it does not include that 7. So that would be just this piece right here. That's the part that's an overlap between a wave pool and a water slide circle, but still outside the hotel circle. So that would be 12. And if we take a look at the notation, it's wave pool and water slide and not hotel. So it's wave pool and water slide and I put the H with the apostrophe, meaning not hotel. So wave pool and water slide and not hotel. I know in the wording it has the word but instead of and, but has the same meaning of and when you're looking at the and or symbols, but translates to and. Okay, so before we look at the common pitfalls, I'm going to double check the chat box again and Q&A to see if there was anything else before we look at common pitfalls. The formula for the Venn diagram. There's a question asking about what is the formula for the Venn diagram. Basically, what we're doing with the Venn diagram is starting, let me go back to a different picture here, like this one. What we're doing with the Venn diagram is we're starting with subsets. Okay. Here's the problem, and we have 85 amusement parks, so that is our box. That's the universal set that we start with, and then we take a look at the information to see what subsets there are. Some amusement parks have a hotel. Some amusement parks have water slides. Some amusement parks have wave pools, and so those would be little circles inside the universal set, which would then look like this. And there's the universal set. So that's how I get started on it. And then to fill in the numbers, you work from the inside out. It's not really a formula. It's just a process of working from the inside of the diagram out to fill it in. And many times that means starting from the bottom of the list of given information. So if we look at the list of given information, we start here with 7. Having all 3 features, and then when I went from slide to slide to slide, I was just moving up this list until we got to the top. So that's the process, a good process to follow with these. So at the bottom of the list, we're told 7 amusement parks had all 3, which starts me in the middle of the diagram, and then we worked our way up the list, which then I subtracted 19 minus 7 to get 12. And then I move up the list again, and I subtract 10 minus 7 to get 3. Move up the list again, subtract 13 minus 7 to get 6. And then I continue to move up the list of given information. Here we have the wave pool circle has to total 22. So I made sure that the region that was left had 16 in it. The water slide circle has to total 30, so I made sure that the region, 55. So I made sure the region left had a 30 in it. And the hotel circle has to total 24. So I made sure there was an 8 here to make sure the total for hotel is 24. And then I added up all the numbers in the picture, which gave me 82. But I need 85, so that tells me in the universal set I should have this 3 right here outside all of those circles. So it's not really a formula to follow, it's more like a process where you're starting from the middle of the diagram and working your way out and subtracting along the way to make sure that the regions have the correct amounts. So let's take a look at some common pitfalls to avoid with doing these problems. When a common pitfall is to start at the top of the given information to try to complete the first common pitfall. We'll start with that one. There's a stop. There it is. First common pitfall is to forget to subtract when completing the diagram. If you notice that from the first example, 42 had a deck, but that means that I didn't write 42 in the diagram. I took 42 minus 30 and got 12. and so that the total in the deck circle was 42. So forgetting to subtract is a common mistake. I've noticed as a common mistake in the past, people writing like 42 right there, but that's not correct. You need to make sure that the sum of the deck circle is 42. So you need to subtract the 30 to get the 12. Another common mistake is starting at the top of the given information to complete the Venn diagram. You really want to start in the middle of the Venn diagram, so that means going to the end of the list of information and working your way up. Another common pitfall is to try to answer the questions before drawing the Venn diagram. The problem with that is the answers are not normally the numbers that are in the given information. So like if you notice, some of our answers were not numbers that were given. So it's really, really hard to do this without drawing the Venn diagram first. Some people, like, I don't know, maybe try to save time, or maybe they don't understand Venn diagrams, try to go straight from the information to the questions, and it's just not going to happen. You're not going to be able to answer them correctly. So the process is to, after you read the problem, figure out how many circles you need. It's either going to be 2 or 3. I haven't seen anything in the homework with more than that. If you add another circle, you're adding way more regions. So it's really just 2 or 3. So look at the number of like subcategories you have in the problem to figure out how many circles you should draw. And then from there, go ahead and label them. And then start in the middle of your diagram and work your way out, starting at the bottom of the given information, working your way up. Fill in the diagram before you even look at the questions. Don't even look at the questions until you have your diagram done. And then you look at the diagram to answer the questions. Doing it any other way is just really hard. It's really hard to get the answers right and doing it any other way. Another common pitfall is to avoid is forgetting to determine the number in the universal set outside the subsets. For example, when we did the houses with the decks and the family rooms, when we added the numbers inside the subsets, we had 59, but there were 83 houses for sale. So some of the houses did not have a deck or a family room, and that number needed to go outside of those circles, but still inside the box. So don't forget to do that, because when you're done, you should take a look at the completed picture and double check things before you start answering questions. For example, let me pull up that diagram here. Before you start answering questions, you need to check some things. For example, with this one, I need to check that my family room has a total of 47 in it. I need to check that my deck circle has a total of 42. I need to check that my entire diagram has the total of, what was it, 83. So, you know, add up all the numbers in the box, make sure it totals 83. So double check things like that before answering questions to make sure you didn't miss anything. Because if your diagram's not correct, it's going to be difficult to get the correct answers, okay? Oh, and there it is right there. The number in the universal set and outside the subsets was 24. So the diagram wasn't complete until I put the 24 in the box outside the circles. So once you're sure that your diagram's correct, then you can go ahead and answer some questions. Okay, so this is just a summary of what we talked about today, and I'm gonna check the chat box and the Q&A box to see if there's any other questions about this before we close up. Okay, so we talked about Venn diagrams and how to use them to do these application problems, especially these survey type questions, and also looked at cardinality notation because you're going to see that in the homework as well. And I just wanted to put my email address up there. Also, my little disclaimer that this does not replace watching the videos in the My Math Lab. It does not replace reading the book in My Math Lab. You still need to do that studying. This is meant to be a supplement to the regular reading and videos for Chapter 2. this is being recorded, so I will send out the link to the recording along with this file that I used today so that your MAT 115 instructor will have that. But if you would like to email me for the file directly, that's fine as well. But this, this is being recorded, so if you want to listen to it again, watch it again, that's fine as well. But I wanted to put my email address up there in case you had so many other follow-up questions for me. Okay, so if you would like the webinar, if you would like the link or the file sent directly to you, just send me an email and I will reply with that. Okay, well, I do appreciate your time and your attention for this hour. I really hope this was helpful, and I want to thank you for joining me today, and God bless. I'm going to stop the recording.